Section 43 is entitled Graphing Lines. Graphing lines. You want to graph the line y equals 2x. If you can say in words what this is saying, if you can say y equals 2x in words, then you have a much, much better chance of graphing this correctly. Another way of thinking of equal is to think it means to get. To get y, you double x. You multiply x by 2. To get y, you multiply x by 2. So I'll pick a few x's and I will double them. I will multiply them by 2. And now I have 3 points. You multiply x by 2 and you get y. You multiply x by 2 and you get y. So I pick x's, I multiplied them by 2, and I had y's. So I plot the point 0, 0. I plot the point 1, 2. And I plot the point 2, 4. Take my straight edge and I connect the dots. And it's done. That problem is done. Let us do another one. Suppose y is equal to 3x plus 4. If you multiply x by 3 and you get 4, that will give you y. For example, if I tell you what I just boxed is 9, if this is 9, then what is y equal? Y equals 9. Y equals whatever this is. If this is 15, then y equals 15. How do you get y? Oh, you multiply x by 3, and then you add 4 to it. Okay? X and y, 0, 1, and 2. I multiply 0 by 3, I'll get 0, and then I'll add 4 to it. That's 4. I multiply that number by 3, I'll get 3, and then I add 4. I multiply that number by 3, I'll get 6, and then I add 4. 6 plus 4 is 10. And since the y values go up to 10, I'll keep that in mind in my scale. I won't let this be 1 and that be 2. I'll say 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. The x's only need to go out to 2. So I can actually space those out. 1, 2. Negative 1, negative 2, negative 3, negative 4, negative 1, negative 2. Okay, 0, 4 is right here. 1, 7. Go out to 1 and then go up 7. And then x is 2 and y is 10. Go out to 2 on the x and then go up to 10. And there's your line. Every point on this line, every one of the points on this line, they all have one thing in common. Just like every point, it has an x and a y value. Let's concentrate on that point right there. What's special? How does that point come to be on the line? You won't believe it, but this y value is 3 times that x plus 4. The line is the set of points, the set of xy points where the y 4 more than 3x. Why is this point xy not on the line? Because when you take that x value and you multiply it by 3 and add 4 to it, you don't get that number. Maybe this point is 1/4. If you multiply that x by 3 and add 4, you don't get 4. You get 7. Okay, that's why those points are not on the line. Okay, let's try another one. First I want to talk about why I've been plotting 3 points. After all, if I just write 2 points, if I just find 2 points, well, 1 point is not enough because there's many lines that go through 1 point. But 2 points would be just fine. That is, if you give me 2 points, this point and that point, there's only one line that goes through them, namely this one. But here's where we run into trouble. What if by error, one of the points is wrong? We made a silly mistake. We get these 2 points, but really, that point was supposed to be there. But you don't know that. And if you knew you made a mistake, you would fix it and there'd be no mistake. You make a mistake and you conclude these are the 2 points, so naturally enough, you're going to draw that line. But it's wrong. It's wrong. If you would have plotted 3 points instead, say this point by mistake, and this point. I hope this is clear as day that these 3 points do not lie on a straight line. So then you go back and you check it and you say, yes, this point was correct. Yeah, that point is correct. Oops, this point is wrong. It should have been there. And then you say, yeah, this makes sense because those 3 points lie on a straight line. That is why it's recommended to plot 3 points. It has a built-in check. Trust me, it's not going to happen that you plot these 3 points, this one is wrong, yet they still lie on a line. It's not going to happen. There's billions and billions and billions of points on this whiteboard. The odds are that you make a mistake and you find the point on that line. It's not going to happen. It's going to be off the line. And then you're going to say, oh, those 3 points don't lie on a line. And you say, oops, I meant the point to be there. Every line can be written in the form y is equal to mx plus b, where m is the slope. Now, every time you talk about a point that hits the y-axis, whether you have a curve like I just drew or a line, every time you hit or cross the y-axis, well, every point has an x and a y value. I claim that every time a point is on the y-axis, you know one of those values. You know either the x or the y value. Now, when it comes to the y-axis, that is the numbers on the y-axis, I can't tell you, oh, this is 1, and this is 2, and this is 3, and that's 4, so y is 4. You don't know my scale. I didn't put any numbers down. The only number that you know on the y-axis is the number right there on the y-axis. That number is 0. When it comes to the x-axis, I didn't number it. could be this is 1 billion, 2 billion, 3 billion. We don't know. Or maybe that's 1 and that's 2 and that's 3. You have no idea what the scale is. But you do know that right at the origin, when it comes to the x-axis, 0 is right there. So, again, those 3 points in black on the y-axis, I claim we know the x or the y value. Since that we don't know the y scale, I couldn't possibly tell you the y value for this point up here, or that point down there, or this lowest point. I couldn't possibly tell you the y value. But you know what? I can tell you the x value. Remember, along this line, the x-axis, I know only one x value. The x value right there is 0. Well, when it comes to this point, when I look straight down, I see 0 for x. When it comes to this point here, when I look straight up, I see good old 0 for x. For this point, when I look straight up, only the number I see is 0. Every time you cross the y-axis, the other letter is 0. While we're at it, what about when you cross the x-axis? Right here and right here. Well, again, it has 2 numbers. Each of these points have 2 numbers. We don't know the x value. We don't know the scale on the x value. But with respect to the y-axis, when I look across, I see 0 right there. When I look across to the y-axis, right where that arrow is pointing, I see 0. These 2 points are called x-intercepts. Whenever you intercept the x-axis, y is 0. These 3 points, naturally enough, are called y-intercepts. The other letter, that's y, the other letter, x, is 0. For the y-intercept, x is 0. For the x-intercept, y is 0. Okay, it's probably the opposite of what might have been more natural. But, nonetheless, that's what it is. So, if I want to find the y-intercept, you let x equal 0. And I'm going to do that in this equation right here. I'm going to let x equal 0. Y is equal to n times 0 plus b. You need to know your 0 table. N times 0 is not m, it's 0. Plus b. Then you need to know how to add 0. 0 plus b is b. So the y-intercept is b. Oh, okay, not a big deal. That's the y-intercept. B is the y-intercept. So if you have y equals a number times x plus a number, that is your slope, including the sign. That is your y-intercept. And what better name to call an equation in that form but the point, slope, intercept. The point, slope, intercept. Thus they give you the slope and the intercept, the y-intercept. So now we have a new way of graphing a line. We don't have to find, say, 3 can be realized or thought of as 2 over 1, and you know that b, the y-intercept, is 4. Now, a lot of students have no problem writing down what I just did, that m equals 2 and y and b equals 4. But then they get lost as to what these things mean. B is 4. That means we intercept the y-axis at 4. Not at 17, not at -9, and not at 2, but rather 4. And the slope, remember, means the change in the y over the change in x. That is why I wanted to write 2 as a fraction. When y changes by 2, x changes by 1. So I go to find another point. I go up 2, and I go to the right 1. And there's another point. You can do this all day. Go up 2, and go to the right 1. There's another point. But you only have to do it once. And there's your 1. I never made the table. I never made an XY table. If I did, I would double x and add 4. I would take 0, -1, and 1. I would double 0, I'll get 0, and then I add 4. I would double -1, that would give me -2. Then I would add 4, that would give me 2. And then I would double 1, which is 2, and I would add 4. That would give me 6. And I would plot those points and I'd be done. In fact, I actually plotted 2 of them. I plotted 0, 4 right there, and 1, 6 was right there. I know it is. There's 1 and there's 6. So if you read off the slope and you read off the y-intercept, if it is in the point slope intercept form, then you can graph it with that information. If I ask you to graph y is equal to -2 over 3x minus 4. So as long as it says y equals, and it does, whatever x is being multiplied by is m, and the constant, why, that's b. Okay, so the y-intercept is -4. So I will cross a -4. And the slope is -2 over 3. That's the change in y. I go down 2. That brings me right there. Let me label my axes. And 3 is the change in x. So I go to the right 3. 1, 2, 3. That brings me right here. What you could do is, you can take the point that you know, the y-intercept, and for the change in y, you take away 2 from the y value, and the change in x is 3, so you add 3 to the x value. 0 plus 3 is 3. -4 minus 2 is -6. And what do you know? That point that I put down right here is -6. If you wanted another point, we now have 3 is -6. You take away 2 from the y, and for the x you add 3. Then you'll get 6, -8. You want another point, add 3 to the x, take away 2 from the y. And you can do this all day long. Now there's another way that one can write the equation of a line. It doesn't have to be y equals mx plus b. It can be in the form of a number times x plus a number times y equaling another number. This type if you had 2/3 x plus 4/7 y is equal to 9/3, you should multiply everything by the LCD. Between 3 and 7, I don't need to say 3 again. Between 3 and 7, the first common multiple is 21. And you will get 7 times 2 times x, which is 14x, plus 7 into 21 is 3. 3 times 4 is 12, times y is 12y. And 3 into 21 is 7, and 7 times 6 is 63. So there it is. An integer times x plus or minus an integer times y equals another integer. Now, if you have an equation of this type, or in this form, you could rewrite it so it's y equals mx plus b, but I don't think one should bother to do that. Suppose you have 2x plus 3y is equal to 6, and you're being asked to graph this. Graph y equals 2x plus 3y equals 6. I think you should play the intercept game. You should find the x-intercept. That is let y equals 0. And you should find the y-intercept by letting x equal 0. And when you do let y equal 0, you have to find x, and next when you let x equal 0, you have to find y. But this is pretty easy. If y is 0, then you have 2x plus 3 times 0 equals 6. But 3 times 0 is 0. So you have, not 3, excuse me, you have 2x plus 0 is equal to 6. But 2x plus 0 is just 2x equals 6. Now, the much quicker way of getting that, and you need to do or few to believe that what I'm saying is happening. If you're letting y be 0, you just cross off the y term. You have 2x equals 6. Exactly what I said. And you should get into the habit of calling x what number? 2 times what number equals 6? Answer, 3. So it's 3, 0. Now we're moving on to this one, where x is 0 and we want to find y. Well, if we know that 2x plus 3y is equal to 6, 2 times 0 plus 3y equals 6, but of course 2 times 0 is 0, plus 3y is equal to 6, and 0 plus 3y is simply 3y equals 6. We could have gotten that much quicker. If we're letting x equal 0, just cross off the x term. 3y equals 6, exactly what we got here. 3 times some number is 6, or 3 times what number is 6? Remember, it's positive 3. If it were negative there, I would be saying negative 3 times some number is 6. Positive 3, which is 3 times some number is 6. Why that number is 2. So again, let us do this one more time. Let us get those two numbers in the boxes. Let me show you how easy it is to do it. 2x plus 3y is 6. 2x plus 3y is equal to 6. In the first case, we're letting y equal 0. That means you cross this out. 2 times y equals 6, 3. When y is 0, x is 3. Then you let x equal 0. That means this is not here. 3 times some number is 6. That number is 2. So, when x is 0, y is 2. And you plot this. Do it right here. Remember, whenever y is 0, you're an x-intercept. The x-intercept is at 3. x is 0, you're on the y-axis. You're a y-intercept, which is at 2. There is your equation of the line. There's the graph of your line. Which line? 2x plus 3y equals 6. Let x be 0, find y. Then let y equal 0, and find x. You could have gotten it to say y equals mx plus b and then do it the old way. But that'd be too hard, I think. Try another one. You have 7x minus 2y equal to 28. Well, let x be 0 and then find y. Then let y be 0 and find x. Well, if x is 0, then this is not here. This is when x is 0. Negative 2 times some number is 28. A lot of students will say 14. Yes, 2 times 14 is 28. But this number is not 2. The number is negative 2. So y is negative 14. Okay, now we take the same equation and we let y equal 0. That means this is not here, including the minus sign. So 7 times some number is 28. That number is 4. 7 times 4 is 28. Okay? So I cross the y-axis at negative 14. And I cross the x-axis at 4. And there is your line. Label the axes. There it is. 1, 2, 3. Okay, now let's go back and do some problems that, although they don't look like it, they're in the form y equals mx plus b. What if you have just y equals 3x? You need to be mathematically mature enough to realize that you can always add 0. Well, you probably know you can always add 0. You have to be mathematically mature enough to write that. So, since it does say y equals, that must be m, because that's x, and there's my b. M is 3 and b is 0. M is 3 and b is 0. M is 3, which is 3 over 1, or 6 over 2, or negative 3 over negative 1. Any way you want to write 3 as a fraction. And b is 0. Okay? So, if b is 0, that means I cross the y-axis at 0. And the top number for the slope is the change in y, and the bottom number is the change in x. So the change in y is 3, I go up 3, and the change in x is 1, I go 1 to the right. And there is your line, y equals 3x. If you just hold that y is equal to 5. Now remember, I told you that these are special points. What can you tell me about all the points on this line? And the answer is, no matter what x is, if x is 5, say, the y value is 3 times it. That's true right here. The y value will always be 3 times x. Why is this point 3, 1 not on the graph? Because when you multiply 1 by 3, you don't get 1. Excuse me. When you multiply 3 by 3, you don't get 1. You get 9. So maybe this should be 2, 6. Every point on the line has the same thing in common. I want to plot all the points where y equals 5. Well, y is equal to 5 along that line. Y is equal to 5 everywhere along that line. But not to worry. If you don't see that, we can still draw this in, or write this in the y equal mx plus b form. Y is equal to, well, there's the 5. Plus 5 is 5. Whatever I put here, that'd be 0. Because only 0 plus 5 equals 5. Well, there it is. There's my 0. 0x. Y is equal to mx plus b. M is 0, which you can think of as 0 over 1, or 0 over 9, or 0 over negative 2, and b is 5. B is 5. Okay? So, I go to b, 1, 2, 3, 4, 5. I know I'm right there. That's my y-intercept. And the change in y is 0. That is, I don't go up or down any. And my change in x is 1. So I go 1 to the left. If you said 0 is 0 over negative 1, well then I would have gone 1 to the left. If you said 0 over 4, I would have gone 4 to the right. But either way, I get this horizontal line. Now things fall apart if the equation doesn't have y in it. When the equation didn't have x, you plugged in 0x. Y equals 9 is the same as y equals 0x plus 9. Because nobody ever said what the number in front of x could be or can't be. We kind of said the number in front of x can be anything. We never gave a restriction on m, but we did give a restriction on the number in front of y. It always has to be 1y or y. You can't have 3y. For the record, if you had, so let's graph this. 2y is equal to 3x plus 6. Since it doesn't say y equals, we have to get it to say y equals to be in the point slope form. We divide by 2. Now, so let me not rewrite on the original problem. So now we have y is equal to 3x over 2 plus, this happens to be 3. This, including the denominator, that's m, and this is b. It must say y equals before you read off the m and the b. Okay, so I know b is 3. That means I cross the y-axis, it's 3. 1, 2, 3, right there. And the 3 for the slope on top, that's the change in y. That is, I go up 3 more. And the 2 is the change in x. So I go 2 to the right, and that's my other point. Again, if you don't like doing it on the graph itself, you can take the point that you know. 0, 3. 0, comma, that number. And then, since m is 3 over 2, positive 3 or positive 2. Do that to the y. That is, add 3 to the y, and add 2 to the x, and you will get another point, namely 2, 6. And you go to 2, 6, and you put your little dot right there. And now you can draw the line. But it has to say y equals. if you have 5y equals, you divide by 5 and you'll get y equals. But what if there is no y? What if you just have x is equal to 7? X is equal to 7. Well, you can bring the x to the other side and you'll have 0 is equal to negative x plus 7, negative 1x. So here you have your m, your x, your plus, and your b. But the other side doesn't have y. You may say, but come on. 0 is the same as 0y, and there's your y. Which is true. But the left side in the end is supposed to have just y. If it was 3y, if we had 3y equal negative 1x plus 7, not a big deal. I would divide by 3. And I would get y equals. But you can't divide by 0. So whenever it's x equals, you can't get it in standard form or point slope form. It just isn't going to happen. So you can't find the slope. That means the slope is undefined. That means it's a vertical line. You want to plot all the points where x equals 7. 1, 2, 3, 4, 5, 6, 7. Well, this point has x equals 7, and so does this one, and so does that one, and so does this one. I know they do. Because if I look up to the x-axis, I see 7 for x. If I look down, I see 7. It's a vertical line. What you need to take with you is that when you have x equals a constant or y is equal to a constant, one of these is vertical and one is horizontal. One of them is vertical and one is horizontal. If you think about it, x equals 7. Either is going to be this line or it's going to be that line. It's going to be one of them. Okay, now you just have to argue through something. If x is 7, that means x doesn't change. But these x's are changing. So it's not that one. It's this one. X is not changing. X changes when you go from left to right. So you can't go left or right. So you just go up and down. If I tell you y equals 7, once again, it's one of these two lines that you see. It's clearly not this bold one because the y values keep changing. Left to right, this line, the y is not changing. It's constant. Okay, so if you want to remember which is which, if x is a constant, it's a vertical line. If y is equal to a constant, it's a horizontal line. And it crosses the y-axis at 7. This vertical line crosses the x-axis at, I meant to say k. It crosses at k. That is, if you want to graph x is equal to 3, since it's x equals a constant, it's a vertical line, and it crosses the x-axis at 3. It is this line. If you want to graph the line y equals negative 2, it's a vertical line, because whenever it's, I meant to say horizontal, whenever it's y equals, it's horizontal, and it better cross the y-axis at negative 2. It will be that line. Okay. Let us do this one last problem. Suppose you're asked to draw a line parallel to the y-axis that crosses this given point. That crosses the point 3, 5. understand that whatever line you draw, it will be parallel to the y-axis. That means it'll be a vertical line. And you know it crosses the point 3, 5. It crosses right here. And remember, parallel to the y-axis, lines that are parallel to the y-axis go like this. They go like that. So, there it is. There it is. That's the line that's parallel to the y-axis, and it really, really crosses 3, 5. If I would have said perpendicular to the y-axis instead, well, perpendicular lines cross at right angles. Well, the y-axis is vertical, so perpendicular lines would be horizontal. So draw a line perpendicular to the y-axis, that crosses 3, 5. Well, here's 3, 5, and here's their y-axis. So you need to go perpendicular to the y-axis and cross 3, 5. That would be your answer. Okay, that finishes the section entitled Graphing Lines. Good luck with it.